I'm sure everyone must have visited a beach. Have you ever seen a beach from a far distance? It seems smooth and plain. But what do you find as you go closer and closer? The beach is made up of tiny sand particles. But can they be divided into something even tinier? And what about those microscopic bacteria? Can these sand particles and bacteria also be made up of something even smaller than them? Okay, let's keep these thoughts aside for a moment and let's first try to understand this idea of divisibility through a simple example. You all must have enjoyed bundi laddus during festival. I'm sure the taste is lingering on your tongue. Now when you look at it closely, you will find that it is made up of small pellets of bundi. And what if we crush and divide it further? We will have even smaller particles. But what if we keep dividing it such that it cannot be broken any further? Such were the thoughts in the mind of Indian sage Maharishi Kannada 2500 years ago. He proposed the idea of Parmanu, which translates to the ultimate particle of matter. Later, Democritus, a Greek philosopher, put forth the idea of atomus, which means indivisible particle of matter. These tiny particles of matter are now called atoms. So now you must answer this. What is the tiniest particle of sand, bacteria or tasty bundi laddu? Yes, it is the atom. In fact, I should be asking, what is the fundamental particle of matter? So all forms of matter, whether living or non-living, big or small, visible or invisible to us, is made up of these fundamental particles called atoms. In other words, an atom is the building block of all matter. So now you know that everything is made up of atoms. But can you imagine how small an atom is? Is this dot the size of our atom? No. Okay. What about this smaller point here? Is this the size of our atom? Not at all. In fact, 1,000,000 of atoms can be fit into this dot. Atoms are so small that they are invisible to naked human eye. Still confused? Okay, let's do a thought experiment. Look at my hand. Let's make a fist out of it. Since my hand is also a matter, it is made up of gazillions of atoms, right? Now, let's imagine what if every atom in this fist is the size of a marble? How big do you think my fist would grow? It will be as big as the size of the earth. So this tells us that atoms are very small. They are so small that if you consider a small sugar cube, it contains as many atoms as there are stars in the universe. Now let's enforce your imagination with actual numbers. So the size of the atom is of the order 1 nanometer. That is 10 raised to minus 9 meter, which is 0.000000001. That's too tiring. Okay, so I hope now you know how small an atom can be. So now we have a fair idea of the size of an atom. But my next question to you is, do you think every substance is made up of its unique atoms? Is it like cheese has cheese atoms, rose has rose atoms, and elephants have elephant atoms, and as humans have so-called human atoms? Maybe. No, actually, it's not like that. If every object was made up of its own atoms, we would have unimaginably large number of atoms. Uncountable actually. Surprisingly enough, the number of different types of atom is finite. A relief. But why do we still see so much of matter around us? It is actually because it's just the combination of all these invisible atoms. So now that you know that atoms are invisible, don't you have this doubt that if atoms are invisible, then why do we see everything that is made up of atoms? Let me give you a hint. Okay, do you see this sand particle in my hand? No? But what about this sculpture here? It is made up of the same sand. Then what makes it different? Think about it until our next video, but for now, it's time to recap. So we've learned that atoms are the building block of all forms of matter, just like a brick is to a house. Atoms are very small, minute particles which are invisible to a naked human eye. The size of an atom is of the order of 1 nanometer, that is 10 raised to minus 9 meter, 10 million times smaller than an ant. There are only finite types of atoms which combine to form various kinds of matter that we see around us. So I hope you'll have understood everything, and here we come to the end of this session. I'll see you next time.